So, probability trees. Never really thought they looked like trees myself. Don't really know what they do look like, but definitely not trees. Anyway, we've got a question here. It's all about a game of chess, and a player can either win, lose, or draw. Win, draw, lose. And it tells us the probability that this person can win is 0.5, and the probability she draws is 0.3. And of course, the obvious thing is that the probability that she loses is 0.2, and the reason for that is that they have to add up to 1. They have to add up to 1 because they are a full set of outcomes. She either wins, loses, or draws. There's no other outcomes. So, Katie plays 2 games of chess, complete the probability tree diagram. So remember, lose is 0.2. So there we are, just put 0.2 there, and 0.5 there, 0.3, 0.2, 0.5, 0.3, 0.2, and again 0.3 and 0.2. And I hope you're thinking to yourself, I hope they put this in my exam. Now, work out the probability that Katie will win both games. So, winning both games, that is this route through the tree. So win, win. So it's 0.5 times 0.5, which is 0.25. Be very, very careful if you get this on a non-calculator paper. And that's winning both games. 0.25. Well, that was hard. Work out the probability that Katie will win exactly one game. Okay, so that's a little bit more interesting. So winning exactly one game. So there's several ways through for this. So she's either going to win and then not win. And I'm going to combine these two together and call them not win. Or she not wins, and she can draw and then she could win. Or she could lose and then she could win. So with this one here, we've got 0.5 times 0.5, which is 0.25. And the second 0.5 comes from this combination here. Here we've got 0.3 times 0.5, which is 0.15 because 3 5s are 15, and then we've got 0.2 times 0.5, which is 0.1. So here we've got win, not win. Here we've got not win, win, and here we've got not win, win. So exactly one game. So you just have to add them up. So it's 0.25 and 0.15, so that's 3, 4, 5. 0.5 is our answer. 0.5. Okay, question 2. 10 socks in a drawer. Wow. People who write these really think of great things to write about, don't they? I'm just trying to wonder what it could be instead. 10 aardvarks in a hole? Who knows? Anyway, Bevan takes at random 2 socks. What an idiot. Who does that? Nobody. Complete the tree diagram. Well, at least we can do that. This is at least a bit more interesting than this implausible situation. So here we've got 7 out of 10, which means that it must be 3 out of 10, which just begs the question where the other grey and brown sock have gone. Maybe left them somewhere. Now the second sock, this is a bit more interesting. You'll be very careful about this because he's taking 2 socks from the drawer at the same time. So that means that the first sock can't be picked twice because it's been taken out, you see. So actually these are out of 9 because there's 1 less sock in. And this is the one thing that can catch you out with tree diagrams. Now, if we're here, that means he's just taken a brown, which means that there are 6 browns left. But there's still the full complement of 3 greys. So there we are. And notice 6 ninths and 3 ninths add up to 9 ninths. Now, if we've gone down here, there's been a grey sock taken out, which means there are still 7, and there would be 2 there. So that's the tree diagram, and that is a bit more tricky. Now, work out the probability that Bevan takes 2 socks of the same colour. So that means we need to consider brown, brown, and grey, grey. And brown is 7/10 times 6/9. 6 sevens are 42, and 10 times 9 is 90. And don't bother trying to cancel these fractions. It's actually counterproductive for a reason I'll explain in a minute. 3/10 times 2/9, which is 6/90. And here is the reason why you don't need to bother cancelling, because if you leave them as they are, you will find that they all turn out to have a common denominator. If you simplify them, you might find they don't. So here we've got 90ths, so we're going to add them up. 42 90ths and 6 90ths makes 48 90ths. And the question doesn't say simplify it, so don't bother, don't waste your time unless you've got a good reason for it. Now, this one of my favourite sorts of problems. This, I hope you've had a good go at it, and I hope I hope you've got it right. Anyway, here we go. So, tossing 4 coins. Now, you could do this with a tree diagram. So you've got coin 1, coin 2, coin 3, and coin 4. And you can see immediately that it's turning into a horrendous mess. So I'm just going to attack it in a slightly different fashion. I'm just going to consider 2 coins. So 2 coins, you could have heads or tails. With 3 coins, you could have head head, head tail, tail head, or tail tail. So there's 4 options. There's 2 options there, 4 options there. Now, sorry, this is 1 coin, isn't it? And that's 2 coins. You can tell it's late. 3 coins. Okay, so we've head head head, head head tail, head tail head, head tail tail, tail head head, tail head tail, tail tail head, and tail tail tail. 1 2 3 4 5 6 7 8. 2 4 8. So you can see 4 coins, 16 outcomes. So coins are fair, 16 completely equally likely outcomes, assuming they're fair coins. So it's going to be out of 16. So the question is, what is it out of? So we need to know how many ways can 2 heads exactly, that's a really important word here, turn up with 4 coins. And I'm going to write them down, see if we can get them all. So we could have head, head, and exactly 2 heads. That means the other 2 coins have got to be tails. Or we could have head, tail, head, tail. Or head, tail, tail, head. Or even tail, head, head, tail. Or tail, head, tail, head. Or tail, tail, head, head. So there we go. Those are our options, and there's 6 ways of doing it. So out of those 16 different combinations of 4 coins, 6 of them have exactly 2 heads. So it's 6 out of 16. That is our probability. Now, if you go on to do A-level maths, or you like to have a little bit of a think about it, there is a way of working this out without actually bothering to do it, all the writing out. You can use, there's a button on your calculator. It's on the school calculator, it's just above the divide button, and it looks like this. NCR. If you wrote it down mathematically, you'd write it like this, and you'd pronounce it N, choose R. And for this one, we would write down how many ways are there of choosing 2 items out of 4, because we've got 2 heads out of 4 coins, and that will give you the number 6. It'll tell you how many different ways there are. Anyway, I hope you found that interesting. I wouldn't worry too much about this thing. This is definitely a question that was on the hard end of GCSE, but to me that's where it starts getting a bit interesting, really. Have a good day, evening, or whatever other time of time you happen to be listening to this in.